VLSos here. This is a video lesson on a power property, quotient of powers. Quotient is the fancy word for division. So this is a property, how to simplify when we're dividing powers. For example, we could have the power x to the third and then divide by the power x squared, a quotient made out of powers. There is a long way to get this answer and justify it. We're going to think of this quotient, but we're going to expand the power. X to the third, or x cubed, means x times itself 3 times in the numerator. In the denominator, x squared means x times itself 2 times. When we see it like this, we're reminded that we can cancel common factors. So we have common factors here. We're multiplying by an x in the numerator and multiplying by an x in the denominator, so we can cancel those common factors. And we can cancel another common factor of x, which leaves just x in 1x in the numerator. The denominator didn't turn into 0, it turned into 1. And we could ignore division by 1 and just give our answer. What's left is x. This is the long way to reason this problem. There's a quicker way to do it using a property. Whenever we have a power of any base b raised to any exponent n, and we're dividing by another power with the very same base, but we could have a different exponent, then we can simplify to create a power with the same base b, and the exponent of this new power will be the difference between the exponent in the numerator and the exponent in the denominator. And this difference, meaning subtraction, has to be in this order. In this subtraction here, the exponent of the numerator must come first. And then you need to subtract the exponent of the denominator. Using this property here, we have a quotient of 2 powers with the same base x. So we can immediately think of this as a new power with the same base x, and the new exponent will be the exponent of the numerator, which is 3, minus the exponent of the denominator, which is 2. And this is the same thing as x to the 3 minus 2 is 1. And x to the 1 is just x. We don't have to list the exponent of 1, we can ignore it. So we have 2 ways to get or simplify this quotient of powers. Use the property to speed up your process. Let's give another example. We could have a power y to the 50th and divide by another power with the same base y to the 20th. Expanding these 2 powers would take a lot of time. This would be y times itself 50 times and divided by y times itself 20 times. We can use this property. If we have the quotient of 2 powers with the same base, and we do, the base is y, then we can turn it into a single power with the same base y, with the new exponent of the numerator minus exponent of the denominator, or y to the 50 minus 20 is the same as y to the 30th. Simplifies quite nicely. One more example. K to the third divided by t to the second. If we take a look at this, we have a quotient of powers. But these 2 powers have different bases. And the power property requires that if we're going to use it, the powers have to have the same base, and they don't. So we cannot use this property. We can't simplify this any further. And we should make a note, can't simplify. And the reason is bases are not equal. So that's finished.